just answering questions with Whack Tech. I'm going to read the question. 3D printed guns will be better and better. The first time I watched Cody Wilson's Liberator that looked like a toy, it could only fire one shot. Now it's much more advanced. And also now it uses off-the-shelf components like barrel liners, and some would say it's cheating that way. But then again, do you just want to make one or make hundreds? Do you want to make it easy for people to make them? Do you even slam fire? Next, have you seen the videos from NYCCNC, New York City CNC? That's a lot of work and hard to get those dies and tools and taps for people who are not familiar with CNC. Okay. Computer Numeric Control, CNC, the automated numerical controlling of machining tools by means of a computer. A computer controls drills, lathes, mills, and also can be used to control 3D printers. That's what they do. The CNC concept is pretty simple. Instead of having an assembly line where you have a bunch of special purpose molds and dies made to make each sheet of metal into the fender or the body panels or whatever, and then you spot weld them together to give them a ridiculous amount of strength compared to what they were when they were kind of floppy, and then welding those to each other, and then drilling holes and then tapping them and putting in special purpose inserts that act for the bolts and then spot welding that stuff. Instead of doing an assembly line where you add parts onto a conveyor belt and add more and more parts until you end up with a complete car, CNCs start off with a lump of metal, and then you drill out pieces of it and grind them and shape them. That's subtractive manufacturing, or negative work. And with 3D printers, it's the exact opposite. You start with an empty space and add material to it until you have a perfectly done thing. Inarguably, they both have their place, and you should combine them. And when it comes to 3D printers, they beat the living shit out of CNC. Anybody can see that. The equipment's cheaper. Instead of anywhere from $1,000 to $10,000 for a CNC startup machine, it's actually much more expensive than that. You can take a 3D printer and have it print better parts to make a more expensive printer. You just need a bunch of plastic that'll melt and work correctly. And then from that, you can actually start off with a plastic and make molds of it if you learn how to mold complex parts, or even the simple ones. Most 3D printers are pretty simple. And just use that to make a mold so you can make it out of metal so it's even more durable. You can make a 3D printer that can make a better one, starting with $200, $500, whatever. Okay, now let's get on to the subject matter that was brought up by this person. The tooling he was talking about that was done by New York City CNC was for making copper jackets for a bullet. Let me explain. The surface of a lead bullet, when fired through a barrel, makes it soft and go into the rifling. If it's fired at high velocity, this also may cause the lead to not only wear off and line the barrel and foul it up, it also can cause it to melt due to hot gases behind it and friction with a bore. Now, cast bullets also have another peculiarity. They can shrink. Normally, you just make a bullet mold that's bigger and you just make it work, but harder alloys shrink less than softer ones, and those are the ones that are normally used for high-speed bullets, but only slightly harder than lead. Less antimony or tin makes it shrink more, also makes it softer. Negating some of this diameter reduction and change effect is the fact that most cast mold cavities expand when they're heated to the casting temperature after the first or second bullet, then they pop out, and the bullet comes out almost perfect. That's why they're slightly oversized if you measure them. And also there's a feed of semi-liquid lead from wherever the sprue is, wherever it won't affect the ballistics and functionality, usually from the back of the bullet, that also feeds it in so it doesn't really squeeze down too much. But one of the problems here is that the lead will foul the lining, that will foul the barrel. So copper has a higher melting point. It has specific heat capacity that's greater than lead. And its hardness is lower than brass and higher than lead. And if you use a copper jacket bullet, either by plating it on heavily or forming it first or forming it some other way, at let's say 0.03 inches thick and making it soft, annealed copper, you can get greater muzzle velocities without fouling the barrel as much. You end up with copper in it, but it's much less than the lead. You have to clean out the copper or it'll screw up the gun eventually. And less metallic deposits are going to be found in the barrel. And it's not as much wear as brass would have, but you can also use brass as well. Some of them even have steel. Some of them are made with the rifling built into it, which is kind of weird, but that did exist a couple of times. Now, the New York City CNC channel shows someone building a punch that does the following. You put in a strip or a huge sheet, doesn't matter, of copper. On one side, it has a negative mold of exactly what the bullet is supposed to be for the whole bullet. If you put a lead, you find the lead out of a jacketed bullet, it's smaller than the bore, it won't work. The jacket is the part that makes contact with the rifling and makes the tight seal. So you have this jacket shape. So you make a mold that's a copy of the bullet as you want it at the end. Looks just like the mold you had. Now the molds normally open like this, where you have a copy of the outline of the bullet sideways. This would be making it to where it was a nose first mold. And the other part is the part that pushes it in, which is a certain number of thousandths smaller, 0.3 thousandths smaller on each side, let's say. And you can make that out of, well, you initially would make it out of fairly weak material like aluminum and use your test material, very thin copper sheet, to where you can push it with your thumb, so you won't have to use hard steel yet. Once you get the mold exactly right, to where it really stretches the copper perfectly from a flat sheet in, you can then also design in a little ring that comes through and cuts it off to where you end up with the jacket having a termination to it. It cuts it off. So that if you lift up your sheet of brass or strip, after you do, let's say, 100 of them in a grid, a 10 by 10, you end up with all the jackets being loose, or at least able to be loosened. You might even make it to where the positive part of the mold goes in, pushes in and punches it, and then the other side, the negative side, has a sheet that pulls off and rips the sheet loose. Now, instead of that, what you're seeing on the CNC channel is him sitting there milling and really working at making one thing that'll make hundreds of things. Run a strip of copper through, makes hundreds and hundreds of copper jackets. Or you can do it like they do in the home of the original Dum Dum bullet, which they had to eventually retool to have jackets. You make a drill bit that drills a hole that matches exactly the bullet shape you want. Doesn't matter what the shape is. And you drill it into aluminum at first. And you make a copy of the same drill bit smaller by just taking the same drill bit after you do all your holes and removing a specific number of thousandths of an inch from the surface of it. It doesn't matter how. And then you use that to drill a hole that you pour metal into to make the negative mold for the back side of the jacket that punches it, this part here. After you've made that, you then copy that by casting it, sand casting, in steel. You just pour iron, steel, whatever. Make it 10 by 10 matrix. And you can also do this where there's holes where the pieces fit in. You can make individual bits so that you can do an articulated rocking back and forth with a negative and positive piece to rip it loose from the copper foil or sheet. And you can efficiently punch out hundreds of bullets in one shot. Ka-chunk. That's for the jacket. The jacket is then put into a holder and it's heated up while you paint the inside of it originally with a layer of tinning flux. It's tin and a flux that makes it to where the tin lines it. It's called tinning. The copper now has a shiny layer on the inside that's very compatible with lead, and if you pour pure lead in it, it'll even mix with it and make it slightly less shrinky. You pour the lead into them and use the bullet's jacket as the bullet mold. And that's exactly how bullets were made at one point. That's one of 100 methods. I just looked up 2 or 3 patents for it one time, a long time ago. Whatever happened to the Dum Dum bullet? Well, the place where it was made, I don't know if it was actually India, the Dum Dum bullets they were talking about, but a place in India that did make them decided to start making non-expanding bullets. Well, technically non-expanding, which is the best kind of thing. What they did is they made molds like this that make it to where the back was exposed with lead, and the copper jackets were there because they were preferred. They made them in all sorts of sizes by just buying a case of bullets, ripping the bullet out, making a copy of it, because to hell with patents and copyrights and everything, just make a copy. You're just making the jacket. Make a bunch of jackets, and then take all of the lead that they had collected from various sources, they still do this stuff today, and just pour it into the molds, and then sprue was literally just the layer, just cutting it off from this whole sheet of negative molds with a copper in it, and then the lead would be over in between them and set. And then they would drop them out, punch, and then move the lead sprue pour-ins to the next location in mass. It would run one plate after another with these negative molds in it underneath a lead pouring bath that would be airtight almost and almost spill no lead at all. And they would get them out at this end and then just run literally a big knife over the whole thing, cutting off the excess lead into the bin, and then pop out all of the jacketed bullets, 9mm or whatever, and then run it back through the machine and make thousands of them a day with a jacket on them. At no time during any of this was anything more complicated than a modified drill bit, or maybe just a piece of soft metal made that they then case hardened to make a drill bit to make these molds. Once the molds were made and made standardized, they just made them. That's one of 100 methods I can come up with that doesn't touch a computer, that doesn't require machining skills of any kind other than you have to learn how to make things. It involves learning to cast things. They used a very fine material, or they used plaster to make them. You just have to bake the plaster first. They drilled things. They made stuff in aluminum or some other soft material. One of the designs even started off with a chunk of copper to do the design in. They just hardened it so that they could kind of make a press for it. And they started off pressing multiple pressings of really thin sheet copper until they got to the right thickness to figure out exactly what they wanted to make, and then figure out how to do the punch outs. This whole process, and there's a dozen variations of it. That's just one really bad thumbnail sketch I just done for you. None of that involved even milling machines, for the most part, except for facing off the surface to be nearly perfectly smooth, making it to where the edges were smooth so they could just keep pouring lead through by pushing one mold through at a time. It would just keep making bullets. No computer control anywhere. But to do the tool and die has been done for hundreds of years without involving computers because they didn't exist at one point. I have seen the videos from his channel. It's a lot of work. It's hard to get those dies. For people who are not familiar with CNC, and then the implied statement here is, you'd need a CNC machine or a 3D printer to do this. Absolutely not. Look up the old methodologies for making copper jackets. They've been around a long time before computers existed. And yes, it is better to make a single item, one, to make your thing on a CNC machine or a 3D printer. 3D printers almost completely replace the need for CNC as long as you do the next stage. You make it in plastic, make it perfect, polish it, fill it in with Bondo, whatever you got to do, and then make moldings of it, if possible, to make the rest of the parts. You're going to have to cut the thing up and make all sorts of sacrifices and hate yourself, but you can do it. Another method for this, if you're not aware of it, let's say you're doing a rifle bullet for 223 or 5.56 NATO. The front of the bullet is pointy. The back of it is almost blunt with a slight in thing and then a flat. There's a part along the bullet's surface, up and down the sides, where it's almost exactly the same diameter. Cut the bullet in half. Just do it. Now you just make a drill bit mold of the front of the bullet and a drill bit mold for the back. You do the same punch out, but not of a sheet of metal. You start off with a piece of copper tubing, and you make the same kind of die thing, and you heat up the end and anneal it, and you slowly mill it down, and not mill it down, but press it down into a press so it's pointy. And then the other side, you don't do anything other than lining it with, I would use tinning flux, and then pour in the lead. In fact, I've actually done this. And you find out exactly how much lead you need to pour in to where it comes in totally level and just the right height, but not quite up to the top. And it's still tin-lined. And then you put it into another mold that's exactly the right shape for the bullet, and then it comes down and crams on the top, folding it in the top, crimping it like you would a shotgun shell, right over the top of it, and it squeezes out just a little bit of lead that's excessive. Or it just crimps it in and it has the lead right up to the surface, and then you clean that off. Now the bullet has the ability, if you crimp the back, to be a hollow point in the front if you want, or a full metal jacket if you don't let it have an empty spot in the front. You can even have an exposed back to make it easier to do the milling and machining, and it will be a match-grade bullet, which is how match-grade bullets were made at one time. They don't all use CNC machines. It's not required all the time. And if you just work on it by thinking really hard, or cheating like I do and look up how people did it 80 years ago, you don't have to buy a CNC machine or a 3D printer. But, like you mentioned, you can make a gun with a 3D printer and blah, blah, blah. You can also make toys. 3D printers eliminate 99% of the wastefulness in CNC or any other machining. And they make perfect starting points to make those molds like you would use for stamping out the fender of a car, and the extra layer you weld together or spot weld together. I'm kind of curious what will happen in the future. But deciding that you're going to make this into an artificial level of I can't do it because you see it done on a YouTube channel, It means you need to go read up on old books. Thanks for watching. Have a good day. Good luck with that.